Okay, so basically the first topic of what I consider to be intermediate algebra is functions, and in particular, they come up as functional equations in the test. Um, but I find that a lot of people don't really even know the definition of a function. Okay. Um, can someone define a function?
Function just maps a set to another set.
That's not a definition. That's like a thing that a function does, yeah? Okay, take number, give number. See that's at least hinting at a definition. Mm, okay, so here I put a definition here. So a function consists, so the notation for a function really, it has kind of three pieces of information, right? It's like a set X called the domain, a set Y called the codomain, and in this case, there's like an arrow between the set X and Y called F, you know? Okay, so most of the emphasis is on the arrow. Alright, but it's kind of necessary to know the sets too. Out of the three, the least necessary is Y. So Y is probably not even necessary. So like the arrow is like necessary and important. X is necessary, and Y is neither necessary nor important. Alright. So why is X necessary? So when you specify X, your function has to know what to do for every element of X. Okay? You can't have things which you can't input into F from X. So everything has to be able to be input. And what does it mean to be able to be input? It means that you can um, get out an output from the set Y for that X. Okay? And sort of the emphasis on the definition of a function is that what Y you get out depends only on the X you put in. So it's like a deterministic process. You know? Okay. And um yeah, and then and obviously every little X in X has to have some Y which gets output, but notice it doesn't say that the Y's have to be different, and it doesn't say all the Y's have to come from some X. Okay. Um and so if you assign the same Y's to the same X, so if the Y's that you assign to the X's agree for between two functions, then they're essentially the same function. Okay. So the function really only distinguishes where each little x goes. So one way you can think of this is the function is like sort of a relationship between the two sets. Okay. And since sets really fundamentally only have one main invariant, and that's size, then functions taking one set to another give you an indication of which set has bigger or smaller size. Okay. All right. Okay, so the thing about functional equations is when most people teach functional equations. Oh, actually, here's an exercise. Maybe I'm. This is hard to. It's hard to do this with the answer already there, but maybe I'll give you another exercise. The point of this exercise is to expose that you didn't actually understand what I said about functions, okay? Because I just went through this definition, and most people just kind of sit there and let it kind of just go past them, and then we just ignore the issue, and then it never comes back up again. But so one like sort of very classical way of testing if someone understands the definition is to basically apply combi to the definition. So, like if you know what the definition of something, then you should be able to count it. Okay. And so usually the first example is like how many functions are there between so I have this on the bottom of the screen now. How many possible functions are there from the set consisting of 1, 2, and 3 to the set consisting of capital A and capital B? So here we've fixed the capital X and Y in the definition, and we just want to show how many kind of arrows we can define that satisfy those conditions. Okay. Probably need someone other than Liam to answer this. Maybe Liam can think about the question, how many functions are there from the empty set to the empty set? Okay, alarm's coming at 5 p.m. That's good. Yeah, what do you guys think? A function from the empty set to an empty set is like Liam talking to Michael. Huh. Liam talking to Michael. So does that mean there is a function? Or there isn't? Oh. Okay, can people tell me when they got the answers of the first part? How many functions are there from 1 to 3 to AB? Yeah, so there's another issue with functions is when you define a function, um, like sometimes it's a scam, okay? Because, for example, when you define like the sine function, the function is meant to be on the set of angles, or basically numbers which represent angles. But what the rule does is it draws like a triangle first. And so the question is, if you have the same angle, but if you draw different triangles, do you get different outputs? And so that's the question of if something's well defined. So, anyone want to tell me how many functions there are? Or if you can't figure out how many functions there are right now, you can also just give me an example of a function. I want everyone to do at least that. Okay, I gotta cap this at. Oh, Alan's already here. Okay, I'm gonna cap this at this moment then. Okay, so if you look at this, all that takes to define a function is to specify what happens to 1, 2, and 3. Okay, so remember everything in the first set has to have an output. And so you got to assign either A or B to each of 1, 2, and 3. And you can actually do them independently. Okay, so that's why there's eight functions. Do people understand this? This is the problem with juniors. They always think they understand, at least the smart ones. And then yeah. Okay, so Liam, is there a function from the empty set or not?
There shouldn't be because there's no values you can enter if a set is empty. Like you can't have something. There's no values in the empty set, so there can't be a function from the empty set to the empty set.
Okay. Yeah, so how would you think about this? So, like the condition on the function is like every x has a y, right? But so then your problem kind of seems to fall under the category like, but there are no y's, right?
And there
So
also
how
are
can
no.
yeah, so the fact that there are no y's is supporting your argument, but the fact that there's no x's goes against your argument, okay? Because having more conditions, having more x's has more conditions you need to do, right? Yeah, so in this case, we'd call it the empty function. Okay. I mean, I think it does satisfy the definition of a function. Okay, because it says every x has y. Well, there's no x. So you don't need to have a y, right?
Yeah, that makes sense.
Yeah. So, but how do you know there's not more than one? Well, it's defined on all the values of x, right? There's no values of x, so the two functions is essentially the same, you know? The empty function. This is because um having no elements in x um leaves no conditions to be satisfied. Yeah, so and also you notice the answer to the other question is 2 to the power of 3, right? Because there's two choices for three things and they're independent of each other. And so this is what gives rise to this funny notation y to the power of x, okay? Sometimes people use that to say it's the set of all the functions from x to y. And usually, since it's sets, a lot of the time you just care about the size of the set. Like, that's why it has this notation, like the actual size of that set is the size of y to the power of the size of x, okay? So this is sort of one justification for why 0 to the power of 0 should be 1, okay? But, you know, um, it's only one perspective. Hmm. Alright, so most people when they learn functional equations, they basically learn all these like stupid tricks to solve like the easy functional equations, or like, how to, like sort of how to use injectivity and stuff like this. I feel like that's not really how you do maths, okay? So when you do maths, a lot of it is just knowing the definitions and kind of working your way towards the result via, minor observations and stuff like this. The tricks kind of should come naturally, okay? So it shouldn't be like a multiple choice test where like you look at the problem and you have a list of tricks and you go down the list until one works and then you do it again until you solve the problem. That's not really, because the point is like if a trick is not on your list, like in that framework, you'll just die, right? But in mathematics, you can invent that trick, okay? Or you naturally come about doing that trick. And so I'm not going to really teach you tricks as part of the theory, but I'm going to give you definitions and kind of let you work with them. So a lot of the time, the definitions, like, they save you time, okay? Because you can naturally come up with the definitions, but like it's easier just to be like, I don't know, like the word injective or one-to-one means that. So you know how we said every x has a y? Well, and we said that the y doesn't have to be different to the other y's. Well, if the y's were different to the other y's, then the function would be called one-to-one, okay? Or injective. Okay, and that's a very natural notion. Okay. And um yeah, so and in practice what it basically the definition is if two things have the same output. So this is the notation for the output when you input A. Okay, and so if something has the same output, then injectivity means it actually had to come from the same input. So every input has a different output, basically. Okay. So in a practical sense, like if you go f of a equals f of b, then a equals b, then what you're really doing is you're kind of just canceling the f's, you know? Okay, so it's a very natural definition, and it's obviously easier just to say, oh, this is injective, than kind of explain every time what the hell injective means, and under kind of somewhat time pressure. Okay, so okay, and if you understood what well-defined means, it's a little bit of a tough ask for young people, but essentially the converse of injective is literally what well-definedness of a function is, okay? So, if you input x, you get out y, and if you input the same x again, you should get the same y again, okay? It should be deterministic. It shouldn't be like you input the same x and you get a different y, okay? And so, in other words, if a equals b, then the output should be also equal, okay? So that's why it's kind of like the converse. So I'm not going to go through all the definitions, but maybe the game that we want to play, that we continue to play on Saturday, you can watch the recording for Saturday for some of the things that's already written here. Okay, but maybe a game we can play is like, so there's two directions. One direction is you look at one of these words, okay, and then you tell me what you think it should mean for a function to be, you know, bounded, for example. And then, or I give you like a definition, and then you tell me which word that should be, okay? Alright, so, yeah. I think we've got identity. So which ones are already done? I think we've done subjective. So subjective means everything in Y, capital Y, has something which some little x which outputs little y. Okay. Okay. All right. Can someone tell me what periodic means?
Right. That.
Yeah. Okay. So yeah, basically. So Charlotte's basically right, but I think one thing I need to emphasize is like as we get older, we'll need to take care of quantifying variables a bit more. So something like there exists an A for which f of x equals f of a plus x for all x. Okay. Okay, can you guys tell me what the definition of an odd function is?
What? Either f of x equals f of wait, I think it's f of minus x equals minus f of x.
Oh, okay. A function f x to y is said to be periodic. X. Function is said to be periodic if if there exists a and x. Actually, does a even have to be an x? I guess it probably should be an x, such that a f of a x plus a equals f of x for all x. Yeah, so if it has addition, it usually has 0 as well. If f of minus x equals minus f of x for all x. Yeah, so these definitions, you're not really meant to just memorize them. You'll kind of see the usefulness of them as they come up. Because it allows you to conclude certain things. Okay, and then maybe I could say if it is said to be something if f of minus x equals f of x for all x in x.
It's said to be even.
Okay, good. You guys know why it's called even and odd? Even and odd are in your high school syllabus as well. So is periodic. So are there any functions which are both even and odd? So there's no numbers which are both even and odd, right? Yeah. Yeah, so can you prove it's the only function that works? Can we prove that it's the only function, or are there other functions?
It's the only function. Suppose another function exists such that both are true for all x. You get f of x equals minus f. So f of x is 0.
So equating both conditions. Yeah, f of x equals minus f of x. No. Yeah, so I'm equating both conditions. You get f of x equals minus f of x for x. Which is the same as 2f of x. Okay, so I need someone to be a bit more, so I'm thinking of maybe another function that might be considered so there's something non-zero. Can you think of anything non-zero? Can you see anything wrong with this proof? What a strange time to be asking this question, right? Just the most innocuous proof ever, and this guy kind of starts bluffing that there's something wrong with the proof. Surely there can't be anything wrong with the proof, but if there wasn't, why would he ask you, right? Huh? Yeah, I guess note the zero function is also periodic, but without a period. It's like
Without the domain is reals or complex. Or is there a domain that condition holds when f of x is 0?
Yeah, I think you got the main idea. So when you do like school maths and functions, like you never have capital X. It's always like, oh well, it's basically always the real numbers, right? Or like it's very clear what it's meant to be. So like when you have um sets which are not subsets of the real numbers, then you can get stuff that's weird. Okay, so one of the things that's not completely rigorous is like, so for example, Ethan said if f of x is positive, okay, so positive is a real number property and it might not be equipped with x. And here I say 2 times f of x equals 0. So the notion of timesing by 2, I think that actually exists just from any additive set, but the notion of dividing by 2 um, is not necessarily universally true. Because, for example, if you do arithmetic mod 2, right? So, like, essentially you can't divide by 2 because 2 is 0, right? So if you do mod 2, this equation here is vacuous. It's just 0 equals 0. And minus sign is also vacuous. So it's actually, so the identity, like, what are functions from, like, mod 2, you know, to mod 2? Um, you can have the identity function, which takes 0 to 0 and 1 to 1, right? And that's, see, the point is minus 1 is equal to 1. Yeah, so the identity function is both even and odd because there's no such thing as minus signs, basically. Okay. Okay. Periodic. I should probably give you an example of well-defined. This is the Monday class, after all. We have some very talented students in this class. Okay. Did I define like the sine function in, I think in the junior book, right? So for acute angles in degrees, we define the sine function that goes basically from 0 to 90 to um, minus 1 to 1. Well, it's just 0 to 1, I guess. Um, Alright, so taking theta in the domain, so theta is between 0 and 90, and what you do is, and you draw a right triangle with angle theta, right? Okay, so you take the right angle theta, you take the angle theta, and then you draw the triangle with that angle, and then you calculate opposite over a hypotenuse. I don't know the SuperToa song. Okay, so the presentation of this definition leaves the question of whether or not it is well defined, which we should try to be aware of and check. Okay? Do people understand why it might not be well defined? So the whole point is it's meant to be deterministic. So when you pick an angle, you meant to get a ratio, right? But in this definition, you just draw any triangle. You draw any right angle. Drawing any right triangle with angle theta. So what if you draw a big one and you get a different ratio to if you draw a small one? Okay. So that's the issue. And then when things depend on some choices, it might not be deterministic, and then you should check that it still works. Yeah, so it works by similar triangles. That's kind of what makes the function special, okay? Because its definition essentially captures what it means to be a triangle, okay? And similarity. So essentially, this function replaces the notion of a right angle triangle, okay? Because what is a triangle? It's essentially a means to associate angles to the sides, right? Okay. Hmm. I don't know. Maybe we can get more motivated to learn some other definitions by looking at the problem. But um, what other things have we not defined? So involution, invertible.
Involution's f of x equals x.
Yeah. Okay. Okay, so involution a function f x to x is said to be an involution if f of x equals okay. Bijectivity. Okay. So more details and a systematic treatment of functions is in the HSC book. I'll just leave that for now. Okay, let's have a look at an example. A5, what does this mean? Determine all functions reals to reals such that f of x squared plus f of x f of y equals x f of x plus y. Okay, so with all algebra questions and equations, essentially you have control over x and y. You can sub in whatever values of x and y you want. So you actually have like a pair of real numbers worth of equations, okay? And the difference is in this equation, you're not solving for x or y, you're solving for f, okay? So another thing you can sub in is you can sub in for f, but more in like a guess and check kind of sense, okay? So we already noticed that f equals 0. If you sub in the 0 function, which is the function that outputs 0 no matter what you input, then you get 0 equals 0 no matter what you put in as x and y. And so the 0 function satisfies the equation, okay? Do you notice any other functions that satisfy this equation? You might want to write this down. We should probably do algebra on a pen and paper.
Identity satisfied.
Yeah, identity satisfies that. Have I written down what the identity function is? Yeah, we say f is the identity function if x equals y and f of x equals x for all x. So that's if you so if you sub in some input and the output's exactly what you put in, that's called the identity function. If the set is not the same set but like a bigger set, you can also have the same rule, but that's called the inclusion function. Okay. Yeah, despite me saying it's 2023, these problems are actually super old, okay? So these problems, like, they always come from like 5 years ago, which I'm only guessing is because they don't want the same the people who have come there to have done the problems before in an actual contest. Okay, can people ask some questions? Do you understand what's going on? So I have 3 perfects for the other one. That's pretty good. 1 decent, 2 neutral. It's already better than Saturday. Yeah, when you do algebra long enough, sometimes you just stop writing brackets for the f's even. Yeah, I should probably write for all x and y after, but because people usually like to save space. In this case, it doesn't matter. But if you look at some of the definitions, like if you just change the order of the quantifiers, you basically get from like one definition to another definition. So in some sense, a lot of the definitions is you just play combi with the combo quantifiers. What I mean by quantifiers is like the for all x, for some x. So like exactly which x does your statement apply for? That's what quantifying means. Okay, so you see that check that f equals 0 and f equals the identity works. Is the problem that ID is already taken? Do you guys see why the identity works?
Yes.
Because f of x plus y just becomes x plus y. Okay, so it's just x squared plus xy on the right hand side. On the left side, like the f's all just disappear, so it's x squared plus x times y again. Okay. Yeah, so in a lot of Maths Olympiad also, like you would just do functional equations as like a small topic because it's like, well, I mean, it's reasonably big in the sense that you can expect it to come up in at least like 5 contests every year, but they kind of just treat it separately to the other things. But understanding the concept of functions is pretty key to modern maths. Okay, so all the geometric transformations, I mean, they're all really the main difference between junior, intermediate, and senior is how much it relies on these ideas of functions. Okay, so functions at the bare minimum is a relation between sets, right? Like the geometric transformations, they're essentially just relations between. So they're essentially geometric functions. So they're the relationships between geometric sets. And we have like additive functions, which are relationships between additive sets. And so if you think of stuff that way, then everything's a function. Okay, what else can we do? So we subbed in f. We should try to sub in x and y's. And why define what a linear function is? Can anyone give me a definition of what a linear function is?
Linear function f of x equals mx plus c.
I want like a proper definition. That's good, but it's not school. Like it's not school where you can get away with saying wrong stuff and you'll get complimented for it, yeah. And it's a good idea, but you need to make it a rigorous definition of a function, okay? X on Y. X on Y would only be the same if f of 0 equals 0, I think. Trying to say the slope is the same, but the slope is only the same if it goes through the origin. Yeah, so essentially the word linear comes from the graph being a straight line. This word linear is reserved for other things later, so it's not the best word here, but it's very common use. So it's actually maybe not we say. It is widely used. It is widely used to say. It is widely. How do you say this in English? It is common to say. If there exists so x equals r. There exists a, b, and r such that, and I think people need to interact a bit more, okay? So if you're watching like a game or something else while this is happening and you don't understand this completely, that's just not on, okay? And I can pretty much guess most of you, there's only like a couple of you, I really think you understand it, and the rest of you need to ask more questions, if nothing, just to stop the conversation for a little bit. No, I think Charlotte and Liam get it, but I also think they're actually concentrating. Some other people I'm not as confident in. Okay, so it's common that if f is linear, there exists a and b such that well, you never even finished off your definition, by the way. F of x equals ax plus b for all x. Okay. The word linear changes meaning when you do linear algebra. Yeah, so usually when you try out functions for functional equations, some of the first ones you try like f equals 0. So f equals the identity, and the one that kind of is kind of like a sort of like almost like a get out of jail free kind of, you don't know what to do, is you try the linear functions. Okay. And then I guess the most extreme version of that is trying polynomial functions, but usually linear, sometimes quadratic is enough, mostly enough. Okay, so this definition also needs a to be non-zero. So usually, so that it's legitimately got x in it, not just looks like it does. Alright, so back to solving this equation. Wait, Liam says he's done it. Okay, so some obvious values to sub in is like x equals 0, okay? So you sub in f equals x equals 0, then this whole right-hand side becomes 0, because it's timesing by x. Okay, so if you sub in x equals 0, and then usually what you do is from there you kind of either keep going down the path that kind of naturally leads you on, or if you find it like difficult to progress, you just kind of take a step back and think about what's going on a bit more. So, what do you get if you have okay, so f of 0 equals 0. So if you do x equals 0, you get f of 0, f of y equals 0. Okay. So that actually tells you something goes to 0. Okay. And so if something goes to 0 and you let the y be that something, then you actually get 0 goes to 0, right? And this doesn't tell you any more information than that, because then that would mean this is already 0. Okay. Substitute x equals 0. Then we get f of 0, f of y equals 0. Or we colloquially, it's funny how colloquially sounds so freaking like not colloquial. Or you might say that f of something is 0. Let y be that something, and we get f of 0 equals 0. Okay, that's good because, well, the functions that we succeeded with both have f of 0 equals 0, and we managed to prove that every function for which this equation is true has to have 0 output to 0. Okay. Yeah, and we also noticed that that's the most the information that can give you. Yeah. Oh, what did you do? Y equals minus x. Huh. Okay. Minus x, and you switch them around. Okay. So like x f of 0 equals minus y f of 0. Mhm. No, so either x, wait, either y equals x or so something where y is not equal to x, so not equal to 0 basically. Okay. Yeah, sure. Okie dokie. Yeah, so you can't get any more information from x equals 0, but now you can let y equals 0 without letting x equals 0, for example. Okay. Can someone tell me what happens if you let y equals 0? Okay, so Charlotte seems to have it. So if you let y equals 0, then f of yeah, so y equals 0 is not the only way to get it. You can do the Charlotte thing where you let x plus y equals 0, or you can try to let like x squared plus f of x equals y equals 0. But the whole point is we got that 0 equals 0. It goes to 0, so we're trying to exploit that. So our second step depends on the first step here. So it's x squared equals x f of x. X squared equals f of x. So if we use Charlotte's negative x trick, if we replace x by negative x, we get x squared as well equals minus x f of minus x. Can you see what that says about f? So Liam thought he solved it, but didn't? Where did Liam just suddenly...
Oh yeah, I did solve it.
See.
I think my method, because I didn't realize x f of x equals minus x f of minus x, because that gives you f of x equals minus f of minus x,
Yeah.
which just trivializes it. Because my method is very much overcomplicated, that led to a triple point wise.
That what Otis is telling you. All right. Yeah, so that's why I don't like people to teach like how to solve functional equations in some like what I'm teaching you right now is like how to solve maths, and it just so happens it's a functional equation. Whereas people like teaching you how to solve functional equation, but like that's usually like reverse engineered from sort of past questions and it doesn't apply. It might not apply to the next functional equation you try, you know? Or okay, I want someone to make a realization here. So remember, maths is about relating things. What does this mean? So Liam already said it, but I want another way of saying it. I should make a poll with are people still here? I can tell if you're gaming, by the way. Have a video in your room and a microphone in your room secretly planted. Yeah, I know you're not gaming because that's
Using
what my
this
secret
method,
microphone video is saying.
using the x f of x and minus x f of minus x only gives you a two-way pointwise instead of a three-way pointwise.
Okay.
Got yeah, the f of x times f of minus x equals minus x squared if f of x does not equal 0 for all x.
So now we see if we can take advantage of the most obvious is y equals 0, right? Which gives f of x squared equals s x f of x. Notice if we replace x by minus x, the left-hand side is unchanged. Therefore, we get x f of x equals minus x f of minus x. Okay, guys, come on. There's a magic word I'm looking for here.
Um, f of x, the function is even.
Yeah, I think yeah, it's odd, okay? And the way to remember which one's odd or even is like odd functions essentially trying to they're kind of polynomial functions where all the terms are odd powers of x. Okay? Even functions are the even powers of x. Okay? Yeah, so to prove it's odd, how do you prove it's odd? Can you prove it?
Um,
Hmm.
divide by x to get f of x equals minus f minus
Hmm.
x. And you can
Okay.
just get from that
Hmm.
by multiplied by minus 1 f minus x equals minus f of x.
Yeah, okay. I guess this is the age where people don't really care about divide by zero. I think that's all I was really asking for when I said, what's the proof, okay? Because I kind of know you know how to divide by x, but the problem is you also know how to divide by zero.
Well, you can assume x isn't 0 basically, or
Yeah, of
at least
course you can, but like, that's not what I asked, right?
true.
I asked people not to divide by zero. So we actually used the definition we just learned, okay? Which is not very common, but common enough to justify having these definitions in the first place. Therefore we get for x not zero. F of x equals minus f of minus x. Yeah, so we know that for every x except for 0, but now we also know f of 0 equals 0, so we actually know it's true for all x. Okay. Yeah. Yeah. I like Charlotte. Very smart. Okay, so combining this with f of 0, yeah, so... Okay, so we got f is odd, okay. So what can we do with f being odd?
You can't do anything with odd yet, really. Using
Hmm.
odd allows you to avoid what I did to solve this, which was messier, because I didn't realize it was odd.
Hmm. I don't know. Should I keep going or do you want to share with your thing?
The next thing to do would be to substitute in f of x equals no x equals x and y equals minus x.
No, okay, so what Charlotte?
Yeah.
Okay, so that's another way to get 0. Okay. Okay. So you're saying y equals minus x?
Yes.
So hopefully people are kind of writing that down on some paper to check that these are all working, yeah? And maybe ask some questions. F of x squared plus f of x, f of... Okay, so minus x, but then it's odd, so you have like a bit more. It's kind of like you can do a bit more with that. Equals 0. Okay. Okay, so this is quite quite a big statement here, because it's telling you anything of the form x squared minus f of x squared, okay, is equal to 0. So things which are of that form a lot, if you can get lots of things of that form, then it's almost a 0 function. Okay. If you can't get things of this form, then it's the identity. Okay.
You can basically, what you can do then is suppose there's an f of u where u is not equal to 0, such that f of u equals 0, because that's assuming if you
Yes.
assume it's not f of x equals plus minus x, then you automatically get there's an f of u that's not equal to 0, such that f of u equals 0.
Yes, the good old f of u. F of u. Okay, so Liam's saying, like, we can consider if something goes to 0 or not. Is that what he's saying?
Saying suppose there's so if it's not just f of x equals plus minus x, then you already have there's an f of u that's not 0, such that f of u equals 0.
Okay. Yes.
And then what you can do, we have f of x squared equals x f of x, so you get f of u squared equals 0. And then you just substitute in x equals u to get f of u squared equals u f of u plus y, and you can range y over all values to get f of x equals 0.
Yeah. Okay, I guess we made some nice. So one concrete thing that come out of that for sure is f could also be the minus identity. Yes.
Yes.
So f of x equals minus x. Yeah. So he's saying if it's not plus or minus the identity, then there's something which gets sent to 0. That's not 0, right? So it's not injective, for example. Wait, oh, another way. Wait. So if it is injective, well, let me just write this. So if you have if you set x plus y equals 0, you get this, right? If it's injective, then f of x equals plus or minus x for all x. If it's not injective, then something non-zero. Yeah, okay. So if f of x, well, if f of u is some u that does not equal to plus or minus u, then if you let x be u, then f of u squared minus f of u squared, like this thing is 0 because that's 0. But the point is this thing inside is not 0. Okay.
I'm saying just f of you can assume that there's, and then you call that thing u. So you
I
get
call that thing.
so you get f of u equals 0.
So let's say f of z equals 0.
Yes.
For some z is not equal to 0. Yeah.
Yeah. Now, using what we have earlier, that f of x squared equals x f of x, we get f of z squared equals 0. Correct?
Yeah.
And now we can just substitute x equals z, and that gives us, if there exists some value f of x that's not 0 such that f of x equals 0, f of x equals 0 for all x.
Oh, you substitute x equals z in the original equation.
Yes.
Oh. So the left hand side 0.
Yes.
You get z times f of z plus y. Is that what you're saying?
Yes. So you can vary y over, because z is non-zero, you get f of z plus y equals 0. And you can just vary y over all real numbers to get f of x equals 0 for all x.
Yes. Okay, this is very good. Okay. Wait, how does the odd thing help then?
Because then you get, because then we have f of x equals plus minus x. If there is no f of z such, which is where z isn't 0 such that f of z equals 0.
Oh, you mean that's to resolve the other case that we...
Yeah. And then that's why it's easy enough to deal with.
Okay.
Although you can solve this without knowing that f of x is odd.
Okay, great. Ray, I'll train you to teach the class for me. That'd be good. Very good. Okay, so...
Right, so...
Alright. So the thing is, just carrying out this, putting things at 0, and getting to this f of x squared minus f of x, Liam has observed enough to make that conclusive. Okay. So basically, okay. Now we consider two possibilities. Okay. Either the thing inside the f is just always 0. So either x squared minus f of x squared equals 0 for all x. Okay, or there is some w in R such that w squared is not for some w in R. Okay. In the first case, f of x squared, okay, I can delete this sum. the writing now. Actually, maybe not, because I need to use this. I'll put it a bit here. So, okay, f of x squared equals x squared. Okay. So, and so f of x equals plus or minus x for all x in R. Okay. So my question to other people is, does that mean f is equal to plus or minus the identity? Okay. So if f of x equals plus or minus x for all x, is that the same as saying that that f is equal to plus or minus the identity? So what is the identity? It's f of x equals x for all x. And what is the negative identity? Is f of x equals negative x for all x. Surely if f of x equals plus or minus x for all x, then it's plus or minus the identity. Okay. So do people agree that that's a sound reasoning? I'll ask you in the form of a poll. Yes, this means it's plus or minus the identity. No, this does not mean it's plus or minus the identity. I see. And there's 4 people who haven't voted. Are these 4 people going to get dinner? I reckon you should get your dinner right after this question finishes. Only 3 people have voted. What is that? Is it Charlotte, Liam, and Ethan? What happened to Lucas and Alon and Ryan? Are you guys in the same Roblox game? At least be in the same game. Oh, Charlotte, Alon, and Liam? Wait, actually, I don't think Charlotte would be insta-vote. Maybe it's, so Liam said he voted. Alon said he voted. So maybe it's Ethan, Alon, and Liam. Okay, then what happens to everyone else? Oh, okay. Not going to be laughed at if you're wrong, so you're laughing out right now. So many misvotes. Okay. Okay, well, We have 5 votes, 4 votes, 1 voted for. Right, we're still missing 1 vote, aren't we? Even with Charlotte not voting. Is Ryan here? Does Ryan's Discord say playing Roblox?
I will check.
He, I think he's worked a way around that. Ryan is a very clever boy. But maybe not clever enough to not play Roblox.
He has probably worked a way around that.
Okay, so okay, we got 3 yeses and 1 no. Okay. So obviously the conclusion is that f is plus or minus the identity, but the
But
just saying
you
that it's plus or minus x is not enough to conclude that, okay?
But so you know my vote is a no, right?
Yes.
Because I voted incorrectly.
Yes.
I'm aware it's a point wise.
Yeah, okay. So basically the problem is that it's plus or minus x for all the x's, but it could be different pluses and minuses depending on what the x is, okay? Whereas for it to be plus the identity, it needs to be all pluses, and for it to be minus the identity, it needs to be all minuses, okay? Called the pointwise trap. And so is often called the pointwise trap. Okay. The issue is that the sign plus or minus may depend on x. And not be consistently minus 4x or plus 4x. Okay. Okay. However, we can still, however, in this case, we can still conclude um hmm. Wait, how do we conclude it? With odd? Let's see. How do we conclude it with odd? Hmm. Wait, can we conclude it with odd?
You can't directly conclude it with.
Hmm. Yes, the odd doesn't quite work right away, yeah, because even it just says that the plus things have to be minuses on the negative side, yeah. I guess a most natural approach is just kind of you take something for which it's plus and something for which it's minus,
Yeah.
and you kind of compare them.
You just suppose there's a y f of z such that f of z equals minus z, and then f of a such that f of a equals a, and then just it's pretty simple to conclude it from there. Just go.
Yeah, okay. All right. That f equals as follows. Okay. Suppose f of something equals s for some s not 0. Yeah. Then f of s Okay, what did you do again? F of s equals s.
And f of another value equals minus that value.
Okay, so you did both. Okay. To get a contradiction, yeah?
Yeah.
F of t equals minus t plus some t not equal to 0. Okay, so f of t squared is hmm. F of t
Yeah. F of squared minus st equals s f of s plus t.
Wait, f of what?
F of s squared
Yeah,
minus st equals x f of s plus t. And then
yeah.
there's just four cases which are very self-evident.
Okay. Alright. F of s squared. So you're subbing in s, x equals s, and y equals t. So minus st equals s f s plus t. Yeah.
And then
Do it. Swap it.
you get four
Four
cases. But
cases. So s
then you
plus
just
t
put
could.
the case you have what? S plus t is either minus, so that side is either s squared plus st or minus s squared minus st.
Okay, good.
And the other side's either s minus st or st minus s squared. And you just show that none of them are equal.
Okay, so basically we show that s squared minus st cannot be plus or minus s squared plus st. Yeah. S squared minus st equals plus or minus s squared plus st. Okay. So if plus, then st equals 0. And if minus s squared equals 0.
And both of those are not true.
Which cannot happen.
So that also.
Yeah. Yeah, so this is essentially just chasing the definition, right? So if those two things happen, something goes wrong, and then so it's either just one or the other. Very good. He is getting good with the logic. Okay. Now in the other case,
The other case is basically symmetrical.
What other case? No. If w squared minus f of w squared not equal to 0.
Oh, that case. But we've already solved this.
F of, yeah, we already said, I'll just type out what you said. That f of z equals 0. Wait, z not equal to 0. Now let x z in the f of x squared equals x f of x to get f of z squared equals 0, and let x equals z in the original equation to get f of 0 equals z f z plus 1. Since z is not 0, we can divide by z. We have f of z equals 0 for all y. And you can just say that this covers all the values, all the real numbers, or you can let y be like, like x minus z or something. Which kind of proves that it covers all the real numbers. Okay, that's solved. Okay, we didn't actually need the odd thing, but I guess not every investigation may lead to the end. Or we might not have seen a good way to use the odd thing, which could have still
Why
existed.
did we make the odd thing?
I just said we didn't.
Well, we needed the odd thing in the first case.
Which case?
You get f of x squared equals x squared.
F of x squared equals x squared.
X that squared equals x squared. You use the odd thing to obtain that.
Really?
You don't need the odd thing, but it dramatically simplifies it. Do you want to know how I did it without using the odd thing?
I don't understand what you mean by the odd thing now. You just mean f of x squared equals x f of x?
No, without using f of minus x equals minus f of x.
Well, where did you use that anyway?
Well, we use that to get f of x squared equals x squared in the first case. Because
For some
otherwise
x.
you have f of x times f of minus x equals minus x squared. And it's harder to deal with that. But that's still possible.
X times f of minus x equals x. Oh, so when you sub it in, you mean?
Yes. Because to deal
So it
with
is
that,
used.
yeah, but you can do it without it. The odd condition isn't needed, but it simplifies it a lot. Because
Wait, is it actually needed? Hold on, because I feel like you sub in S and T, right?
wait, there's another way to do it without actually using the odd thing.
But I still don't see how you use the odd thing.
You use the odd thing to obtain f of x up to equals x up to.
Wait, what do you mean you get the odd condition in the end anyway? Where did you use the odd condition? Wait, Liam, keep going.
Because when we assume the only value such that f of x equals 0 is when x equals 0, what that gives you is f of x times f of minus x equals minus x squared. And to obtain f of x up to equals x up to, that's where we use the odd condition. But you can still avoid using the odd condition and solve the problem.
Alright, I'm confused. So is it before the S's and T's or after it's been introduced?
Before the S's and T's.
So you're saying we use the odd condition before the S's and T's?
Yes.
Is it before the W's?
In that step, to get x squared minus f of x squared equals 0 requires you to use the odd condition.
Okay.
But there is a way you can completely avoid the odd condition.
So odd is used here. Yeah, there, right?
Yeah, but do you want to know how you can avoid using the odd condition completely? You can solve it without the odd condition.
Oh, no, I'm fine, I think. I'm just kind of.
Right.
Can you give me a sketch without going into the details?
You substitute in x equals f of x and y equals f of minus x, and then you can use your f of x times f of minus x equals minus x squared to get f of x squared minus x squared equals f of x times f of x minus f of x squared minus x squared, and then that basically gives you f of x equals either 1 minus x or plus x for x. And you just
Okay.
the one
Yeah, okay, that's a pretty good idea, you know? So Liam's idea was basically, this tells you that x times f of x is equal to f of x squared. So he made this this x f of x and this y like, I guess, just x or something.
F of x. That was minus f of x.
Minus f of x. Oh, so it's the second one.
Yeah, what that directly gives you is f of x squared plus f of x times f of minus x equals f of x times f of x plus f of minus x. But you can use some other substitutions to get that thing. So it's I think harder than what we did.
Yeah. Yeah, I mean, sometimes, you know, it's good to do it the harder way because sometimes you get more strength, but you need to be able to also do it the easy way so you can survive more as well.
Yeah,
Usually,
somehow I realized the harder way before I realized the easy way.
I mean, that's usually the case. Because it's sometimes easier to like explore the terrain inefficiently and then find like the shortcut, right?
Yeah, the shortcut here, like the x f of x equals x minus x f of minus x is pretty easy to obtain.
Hmm.
So getting the hardware was probably just not doing well.
All right, guys. So maybe get your dinners in front of you somehow. Get something to drink. Go to the toilet. Um, Let me know when you get back. Wait, hold on. Before you go, Charlotte has an idea. Let's do Barry Bash. Oh, you're like my favorite student. Barry Bash. Yeah, it'd be funny though. We just need to get a person named Barry in Tuesday class, and then we all join Tuesday class. Okay, so yeah, get your dinner. Get your dinners ready. I don't quite have Barry Bash planned, but I don't know. If we're really good, maybe we can get to it. But there's quite a lot to get through today. All right, just message me when you get your dinners. Yeah, when you're back and ready to go. Okay, give you a message.